Okay, I welcome you to my DBA defense presentation. My name is Mr. Masialeti. My research topic is an empirical study of short interval control tasks and mobile technology fit in an underground mine. Professor Jean Fabrice Rebrand supervised this research. In this presentation, I'll cover the different aspects of my research, starting with the research background and ending with conclusions, limitations, and recommendations for future research. Mining has existed for many centuries. It continues to contribute to many countries' economies in the world. However, some core business processes within mining are still being done manually or semi-manually. Examples of such a process is short interval control. Many mining companies are adopting a digital transformation strategy in order to achieve some of the benefits promised by digital transformation. The World Economic Forum study published in 2017 reported that digital transformation has potential to contribute $425 billion US dollars if it is implemented successfully across the global mining industry. In this vein, some of the mining companies such as BHP, Rio Tinto have implemented digital transformation such as autonomous trucks in order to achieve some of these results of digital transformation. Companies such as Barrick embarked on a journey of advanced data analytics and also digitizing the short interval control. This study focused on the digitization of the short interval control business process using mobile technology in an underground mine. Short interval control examines operational data at short intervals to identify deviations. It employs the plan, do, check, act continuous improvement model. Therefore, short interval control serves as a formal framework for managing shift tasks and evaluating actual performance against anticipated output. This business process enables supervisors and miners to make mid-shift adjustment to increase overall production efficiency. So while there are many studies that have been done on task technology fit, there's lack of empirical evidence to explain short interval control tasks and mobile technology fit or misfit and impact on miner reaction. Understanding mobile technology is very important because that will result in getting the benefits of digital transformation and supporting the future development of what are called smart mines. Therefore, in this study, the research question that was addressed was, what are the implications of short interval control tasks fit and misfit with mobile technology applications used by operation level miners in an underground gold mine? In information systems, there are a lot of models that have been developed over the years in order to understand how information systems impact performance. This specific study used the task technology fit model proposed by Godwell and Thompson in their paper published in 1995. This paper was published in the MISQ journal, one of the top-rated information systems journal. And this model is used as a foundation theory for this study. This model proposed that if there's a fit between the task characteristics and the technology characteristics, and the technologies utilized, this will result in individual performance impacts. Over the years, the task technology theory has been used by many researchers, with Spies and colleagues publishing in 2020, suggesting that the use of task technology theory can be classified into two streams of research. One stream of research assesses phenomena. In this case, it applies the task technology fit theory in different industries, such as education, health, and banking. The other stream of research generates theory, in which case it extends the task technology fit theory by combining it with other theoretical frameworks such as UTAUT and TAM. This specific study used a refined and extended task technology fit model proposed by Howard and Rose. In this model, Howard and Rose introduced the concept of task technology misfit. The task technology misfit can be classified as being too little or too much, and these were introduced as separate constructs in the model. By task technology misfit too little, Howard and Rose 2019 explained that when technology does not include the desired features to perform a task, task technology misfit too much might occur when an applied technology includes too many features to perform a task. Thus, some of the key hypotheses that are worth explaining, because this was a very complex model, are that mobile technology characteristics positively influences task technology misfit too little. Mobile technology characteristics positively influences task technology fit. Mobile technology characteristics positively influences task technology misfit too much. Another one worth mentioning is task technology fit positively influences underground miner reactions. Task technology fit positively influences utilization. Task technology fit positively influences underground miner performance output. Lastly, but not the least, utilization positively influences underground miner performance output. This study was conducted at the Turquoise Ridge Underground Division, a gold mine owned by Nevada Gold Mines, whose majority shareholder is Barrick Gold Corporation. The mine is located in the state of Nevada in the United States of America. At Turquoise Ridge Underground Mine Division, the digital short interval control uses mobile technology and works as follows. First of all, the tasks are generated based on the mine plan, and these are assigned to the miners, and they show up on the mobile applications, on the mobile devices that are used by the miners. As the miners go mining underground, they are tracked, as well as the equipment is tracked using an application, a mobile application called Mobile app, which is part of the short interval control suite of application. The work status of the task is updated on the mobile devices and mobile applications, and these are viewed in a command center where all the works for the underground mine is viewed. Now, whilst the miners are working underground, changes might happen. This might be maybe where they are mining, the area is not safe and they need to move elsewhere, or maybe there are certain places where they need to focus on in order to get the ore. These changes, in order to adapt to the changes in the environment, is what the essence of short interval control is, because the information is communicated and the miners and the supervisors are able to make changes and adjustment in order to meet production targets. In this specific study, the target population was 400 employees. However, only 106 employees responded to the survey. The study used measures from previous studies. The data was collected in two stages. The first was the pilot study, in which case I was able to get feedback on how the questions were structured, and I was able to use this information to refine the final questionnaire. Lessons that were used from the pilot study helped in refining the final questionnaire. There are two types of analysis that I did. The first was descriptive statistics that I used on the 106 responses. Here I used the SSPS software. Some of the key things that are worth mentioning on the descriptive statistics is that, as can be seen, most of the respondents were aged between 30 to 39, and mainly from the general category of miners, with most of them having 1 to 5 years of working experience. This is important because it shows the changing demographics within mining, where a number of millennials are joining the mining industry, and these are very adaptable to the use of mobile technology. The other analysis that was done used partially square structure equation modeling, and I used SmartPLS software. The procedure that was followed is the one that is suggested by Hare and the colleagues in the book published in 2017, where they suggested that, first of all, the structure model need to be specified, and then the measurement model need to be specified, and these should be run in the SmartPLS software, after which both the measurement and structural results need to be analyzed and also checked for reliability and validity. This was the output from the SmartPLS software. As you can see, the blue shows the latent variables, which are the main constructs of the model that was tested. The green shows the mediating variables, and the yellow shows the observed variables on the latent variables. Some of the key results that are worth mentioning is that, as can be seen, mobile technology was found to positively influence task technology misfit too small. It also positively influenced task technology fit. Mobile technology positively influenced task technology misfit too much. This shows the key role mobile technology plays and how it influences both fit and misfit in the way the short interval control tasks are used. The other result that is worth mentioning is that task technology misfit too much and task technology misfit too little was found to negatively influence underground user minor reaction, utilization, and performance output. This suggests that if the technology does not possess the necessary features to complete the task effectively, the user may perform worse and they may have negative reaction to the technology. Even when the technology has excessive features, this might cause some confusion and the users may be overwhelmed, whereby worsening their performance output. One of the other interesting results is that task technology fit positively influences underground user reaction. It positively influences utilization. Task technology fit positively influences performance output. This result is very good because when you've got a match between the tasks and the technology, this will result in these better outcomes of good positive reaction from the user, as well as better utilization of the technology and performance output. As can be seen, organizations should work towards achieving the fit in order to be able to get the full benefit of the technology. There are some results that were found to be non-significant, and I performed the post-hoc analysis using the G-Power software in order to understand the statistical effects. The sample was found to be sufficient because the suspicion was that maybe the sample was not sufficient. Also, looking at Giffen and colleagues in the study that they published in 2000, in which they suggested that the minimum sample should be 10 times the total number of observed variables on the most complex construct. In my case, the most complex construct was underground short interval control task characteristics, which had 10 observed variables. And if you multiply 10 by 10, that was 100, and had 106 responses, which was enough for me to conduct the analysis. Therefore, the non-significant results are not because of the sample size. Some of the key theoretical contributions of this study is that the task technology fit was used in an underground gold mining context. The current study applied the refined task technology theory, and by using the mining specific constructs, such as short interval control, this model was extended in a unique way. This is the first case in which task technology misfit construct proposed by Howard and Rose in their paper published in 2019 has been used in an underground mining context. This study has proposed that the task technology misfit construct that are used in mining can play an important role in order to understand how the technology can better be used by the miners. In this specific study, I've made an assertion that task technology fit actually can be on a continuum where it starts with task technology misfit too little, and then in the middle, you can have a full match between the task and the technology, and then you can also have task technology misfit where it is too much. And this can be part of the future studies that will be carried out. Some of the key managerial recommendations are that for organizations that are deciding in investing in the digital short interval control, they should be able to make an assessment whether they should buy off-the-shelf software or they should develop one in-house. My recommendation for mining organization implementing digital short interval control to use an off-shelf configurable application and also partner with a software development house. This is because mining companies, their core business is mining, and it is not software development. And therefore, by partnering with companies that are focused on software development, this will enhance the value and improve the features of the technology in order to achieve fit. These features that should be part of this customization of the short interval control system should be developed based on the value that they are going to add and how they will help in attaining the fit. And this should be able to drive the prioritization of the enhancements instead of just listening to who screams the most in terms of the features that they want. These enhancements should be deployed using an agile methodology so that the features can quickly be added to the software and the miners can use them. And in case the miners, they've got feedback, that feedback can quickly be given and the features can be added. The use of the collaboration technologies as part of the short interval control suite of application should be something that should be taken into consideration, because collaboration brings a more decentralized approach around how the short interval control system is used, because the miners, they are able to communicate to each other directly than the traditional way in which short interval control system is used, where everyone uses the radio system and there might be congestion, and sometimes they have to go through the command center in order to communicate with others. The other recommendation is that mining companies that are implementing digital short interval control that uses mobile technology should implement a mobile device use and safety policy so that the miners can know the rules around how the mobile devices should be used. This is because when they are working underground, there are a lot of hazards that might be there, and you don't want a miner who is driving a big truck at the same time they're using a mobile device. So maybe some of the rules might be for them to check through the mobile device. They should be able to park the truck, or the mobile device should be properly mounted within the truck so that as they drive, they're able to look at the mobile device in that way. These results and the recommendation were summarized using a table adapted from Kalika's book published in 2020, which proposes a way in which you can better summarize the DBA impacts. As can be seen, one of the first recommendations that was prioritized is how the mobile technology can be able to be used better. That is, because of the understanding of how the mobile technology effects impact miner reaction, how they impact utilization, and how they positively impact performance. This one, I was able to prioritize it in terms of implementation. I work as a service delivery manager, and therefore I was able to work with my team in order to improve the support model of how the miners use the mobile devices. So the support model has been working great, and there's a lot of great feedback that has been gotten from the miners who are now able to use these mobile devices effectively and use the SIC systems to realize the benefits of using such a technology. Further, there's been a lot more collaboration between the support team, and there's a lot of feedback that we've gotten from the miners in improving how the short interval control system is used, whereby we are able to support the change management process as well as part of our team. In the early stages of implementing this, Agile Scrum was also used in order to prioritize some of the features that are used by the miners. So the main goal of this study was to answer the research question: what are the implications of short interval control tasks fit and misfit with mobile technology application used by operation level miners in an underground gold mine? The question can be answered finally that the implications of it are that it results in better prediction, thus allowing for better decision-making around improving the short interval control process, which results in better performance of underground miners. However, when you've got misfit, it implies that it is unpredictable and therefore makes it challenging to make decisions on improvement. Thus, this might negatively impact performance. Therefore, in addition, we can assess the difference between fit and misfit in terms of capability and capability of performance prediction. One of the limitations I had in this study was because the data collection was conducted during the time of COVID-19, and therefore I did not have all the personnel available to be able to respond to the survey. However, as was explained, the post-hoc analysis results showed that the sample of 106 was sample for me to perform the analysis. The study focused on one case study, and therefore this might impact the generalization of the results. Therefore, future research should focus on replicating the study in other underground mining contexts that mine coal, silver, copper, and other minerals. Further investigation should be done as to whether the mining methods and operation processes might influence the mobile-enabled short interval control tasks and the influence this might have on task technology fit. There should be consideration and further investigation, as earlier explained, on how task technology fit and test technology misfit can be on a continuum. This study used individuals as a unit of analysis. Future research should consider using group as unit of analysis. Thank you so much for attending my defense.